Hello students, welcome back to my channel where I teach fundamental concepts of physics and chemistry in a more simplified way so you can easily use what you have learned in my page in your real life setting. So far, I have discussed about topics in distance and displacement covering two lessons. My first lesson is about distance and displacement in a straight line, and the second lesson is distance and displacement into two directions. We have learned so far that in a straight line, distance and displacement are equal, but not into two different directions, where we use Pythagorean theorem in order for us to compute for displacement. Now, what if your teacher give you another scenario, which comprises of different directions in one problem? Here, let me give you an idea. What if your teacher give you a task in order to determine the distance and displacement if you walk eastward, turn southward, then move eastward again, and then move southward again? How are we going to compute for distance and displacement? First, let us identify the magnitude of each direction. First, you have walked 5 meters due east, then 10 meters due south, then 10 meters due east, and then 5 meters due south. So, how are we going to determine the direction and, of course, distance and displacement of this example? So remember that distance is simply the addition or the sum of all of these magnitude. That's the most easiest part so far. So if we're going to compute for distance, simply d or distance is equal to 5 meters plus 10 meters plus 10 meters plus 5 meters, and we got correct 30 meters. This would be our distance. But how about displacement? You have learned in the second lesson that displacement is a measure of the distance from the initial point up to the final point. But in this example, we cannot use the Pythagorean theorem because, as you can see, we cannot form, or we do not form, the perfect right triangle for each directions. Look at this part. As you can see, there are missing part right here that we cannot compute if we do this. And we have many sides to consider. So how are we going to simplify this? To do that, we're going to use vector addition. Vector addition is simply addition of these magnitudes, but this time we are going to consider their directions. We have learned that we have 4 cardinal directions, namely north, east, west, and south. And each direction can be positive and negative. North and east are both positive directions. West and south are both negative directions. Recall your Cartesian coordinate plane in your mathematics. Now, how are we going to apply this? Okay, let us try first to combine directions which are both horizontal and the other one which are both vertical. So, our horizontal direction is this and this. So we're going to combine them both. So we have 5 meters, and since it is east, it should be positive, right? And then another one, 10 meters, which is also positive. So we got 15 meters to the east. Now, let us try to compute for those distances which are vertical directions. So one is negative 10 meters, because it is due south, it should be negative. Then another negative 5 due south also. And we got 15, right? 15 meters south. You might ask, where is the negative sign? Remember that negative sign indicates direction. And since we write the direction, we're going to remove the negative sign. Now that we know this, we can already redraw the path took by John from school. Okay, let me use another page for our example. Okay, again, we get 15 meters to the east and another 15 meters to south. So we're going to draw that 15 meters, then another 15 meters. Mhm. Okay, let me just do it right. 15 meters and another 15 meters. Okay, so let's write it. 15 meters east and 15 meters south. Okay, now, how are we going to locate or to measure our displacement? Since we already have our right triangle, we can now use the Pythagorean theorem. Again, the Pythagorean theorem states that c squared is equals a squared plus b squared. We can assign first the number. We have here a, b, and c. The letters, I mean. Oh my god. Okay. Then substitute the values into the formula. C squared is equal to 15 meters, going to square them both, plus 15 meters, and then square them both. And since we only need c, we have to remove the squared of the c. And in order to do that, we have to square both sides. Square root both sides. The square root of c squared is c. And then, before we get the square root of the following inside the radical sign, we have to simplify it first. What is 15 times 15? In order to do that, we will be using our calculator. Okay, let me just open my calculator. Here we go. Okay, let me just make it the smaller one. Okay, so we have 15 squared is 225. Meters times meters is meters squared plus 225 meters squared. And then we get 225 plus 225, we will have 450 meter squared. And if we're going to compute for the square root of 450, we will get 21.21 meters. That would be our displacement. Let me write it now. Our C this time is 21.21 meter. We have found our displacement. That is very easy if you follow the step correctly. So for a bonus lesson, since this is our last, what if your teacher give you this scenario? You walk again, you walk again, and then you went back from where you come. Let's say that is perfect square. So if you encounter this scenario, you just have to remember that displacement is a measure from the initial and final position. And since you went back from where you belong, there will be no distance between them. So displacement should be 0. Okay? Do you understand it? Okay, I'll give you another one. What if we have this one and this one? How are we going to compute that? Let's say this is 5, this is 3, and this is 2. Remember, combine horizontal and vertical. Let's combine. 5 is due east, so that would be positive. 2 is due west, that should be negative. And the resulting difference is 3, positive 3. And then, of course, our vertical, we just have to copy it 3. So, okay, so this is our horizontal line. So will be our vertical line, which is also 3. And all you have to do is redraw it. 3 to the east, because it is positive, it should be to the east. And of course, 3 to the south. Okay, because we don't compute for the south part, because there's no other line towards south. And then all you have to do is to connect both, and then you can start using the Pythagorean theorem to compute for that. That's very easy. And I hope you understand. Learn something new. Just forgive me for my stuttering sometime because I don't have any script to follow. So, if you have any question, clarification, feel free to leave a comment. I will do my best to give you an answer immediately. Thank you so much for listening and enjoying learning with me. Goodbye.